Welcome to this lesson and thank you for joining us. Today we are going through chemistry revision, a flowchart, and the question that we have reads, study the diagram below that shows some reactions of dry air, then answer the questions that follow. Our flowchart begins from dry air, and we know air is a mixture of gases. Present in air we have oxygen gas, we have nitrogen gas, we have carbon dioxide, we also have noble gases, but the major component under noble gases is argon. We also have water vapor, but since we have dry air, water vapor is absent. So let us begin from dry air going downwards. We have air reacting with magnesium, and air being a mixture of gases, there are only two components that react with magnesium, that is heated magnesium metal. We have nitrogen gas and oxygen. So magnesium, that is heated magnesium metal, combines with oxygen to form magnesium oxide. Magnesium also combines with nitrogen to form magnesium nitride. That is, magnesium has a valency of 2, nitrogen has a valency of 3, giving us magnesium nitride. Then we have now solid B reacting with water to form gas X and substance C. So to know which one is solid A and which one is solid B, magnesium oxide reacts with water to form magnesium hydroxide, and therefore there is no gas produced. So it is magnesium nitride that reacts with water to form magnesium hydroxide and ammonia gas. So solid B is magnesium nitride. Then now solid A becomes magnesium oxide. Then once magnesium nitride combines with water, it forms substance C, which is magnesium hydroxide, and gas X, which is ammonia. Let us also go to this other direction. We have heated copper metal combining with air, and remember, air being a mixture of gases, there is only one component of the air that combines with copper, and that is oxygen. So copper reacts with oxygen to form copper 2 oxide, which is solid F. Then of course now we have a mixture of gases. Since it is only oxygen that has been eliminated, this mixture of gases contains nitrogen, it contains carbon dioxide and argon. Then this mixture goes through sodium hydroxide, where carbon dioxide is absorbed. Then now the gas Y will be a mixture of nitrogen and argon under noble gases. Remember, noble gases are unreactive, and therefore our main target is nitrogen as gas Y, and argon being here is an impurity. Then we have gas Y coming down, where it reacts with gas D under the given conditions, that is 350 atmospheres, 450 degrees Celsius, and finely divided ion. These are the optimum conditions for the production of ammonia, and therefore since gas Y is nitrogen, then gas D is going to be hydrogen, such that the mixture of hydrogen and nitrogen produces gas Z, which is ammonia. Now we can go through the questions. Identify solid A. Solid A is magnesium oxide. Magnesium oxide, MgO. We have solid B. Solid B is magnesium nitride. Magnesium nitride. That is Mg3N2. Then we have gas D, and gas D is hydrogen gas. Next we have gas Z, and gas Z is ammonia gas. That is NH3. We move down with the questions. Why is the amount of solid B obtained less than solid A? Remember, solid B is formed when magnesium reacts with nitrogen, and solid A is formed when magnesium reacts with oxygen. But solid A is more than solid B. This is because the nitrogen gas is less reactive compared to oxygen that is more reactive. So we can say oxygen is more reactive. Oxygen is more reactive than nitrogen gas, hence reacts faster, and completely with magnesium. Nitrogen gas is less reactive, and remember, nitrogen gas is less reactive because it has a triple bond that requires a lot of heat energy to break. And we can say little nitrogen reacts with magnesium. And because of that, magnesium nitride is less compared to magnesium oxide produced when magnesium reacts with air. C part of the question. Write a balanced equation for the reaction between solid B and water. Solid B is magnesium nitride, which is a solid. It is reacting with water. Water is a liquid. And the reaction between magnesium nitride and water produces magnesium hydroxide. Plus gas X, which is ammonia. This equation can be balanced, so we write 3 behind magnesium hydroxide. We can also write 6 behind water so that we can balance the hydrogens. Then we can write now 2 behind ammonia so that the equation can be balanced. We go to part D. How can gas Y be obtained from gas X in the laboratory? Remember, gas X is ammonia, and we want to obtain gas Y, and gas Y is nitrogen. So for us to obtain gas Y from gas X, we simply pass gas X through heated copper 2 oxide, where gas X is reduced to nitrogen gas. Pass gas X, that is ammonia gas, through heated copper 2 oxide, where ammonia, where ammonia is reduced to nitrogen gas, and this is the gas we are looking for. The next question we have is write an equation for the process that takes place in D Roman 1 above. This is the reaction between ammonia gas and heated copper 2 oxide, a solid. This reaction produces nitrogen gas. Then of course copper 2 oxide is reduced to copper metal. Then ammonia is oxidized to water. Ammonia is oxidized to water. Water is a liquid. We can now balance the equation. We can write 3 behind water. We write 3 behind copper 2 oxide, 3 behind copper, and then of course 2 behind ammonia, so that the equation is balanced. Then now part E of the question, which gas is absorbed by sodium hydroxide in step 1? And we have seen in step 1, the gas that is absorbed by sodium hydroxide is carbon 4 oxide. We have part E, carbon 4 oxide. Remember to subscribe to the channel and also help us to share the link. We go to part F. Gas Y obtained in step 1 is impure. Name one impurity it contains. We have already seen that gas Y is nitrogen, and the nitrogen collected in this step 1 contains noble gases as the impurities. So we are supposed to name one impurity, and one impurity in gas Y is argon. We can also name a gas like neon. We have xenon and any other noble gas in that particular case. Then what name is given to the process in step 2? Step 2 is where we have hydrogen and nitrogen combining to form ammonia, and ammonia is manufactured or prepared by a process called Haber process. Haber process. Thank you for watching and welcome to the channel. And in case you have questions, you can kindly interact with us in the comment section, and we shall be glad to address your concerns accordingly.